Absolutely. Awesome. Thanks so much, Derek. Let's move on to our next segment. I'm going to bring on Byron Ruth. He's our director of developer relations here at Synadia, and him and I are going to go over a really fun progressive demo and kind of talk about this idea of microservices. So, Byron, welcome
Hey.
to the conference. Welcome to the stage.
Yeah, it's
It's good to
exciting.
have you.
Thank you.
I know you've been working a lot behind the scenes organizing this, and this has been super fun to kind of watch all of this come together. And I think we have a lot of really cool stuff in store to share. So I think we should just get straight at it.
Sounds good.
All right. So let's move on to transcending microservices with NATS. Byron, you want to kick off this first part?
Yeah, sure. So I think whenever there's these topics on big topics like microservices, there's a lot of things to be able to talk about. I just wanted to throw this first slide up there to say these are all different decisions and things that you can make and evaluate. These are not the things we're going to be talking about today. If you have questions about them, we happily have opinions. So feel free if you're curious about any of these things. But I just wanted to sort of call out the fact that if you're here and you want to learn about microservices or you're running microservices in production or what have you, we're really focused on how NATS can kind of help facilitate and simplify microservices for you. So just wanted to throw that out there. But feel free to ask questions if you have any. All right. So as noted, microservices is not a free lunch in and of itself. It brings complexities. So that's just kind of something to keep in mind. So I think really it's useful to focus on why may you require microservices. So we certainly don't want to advocate for people to move to microservices for the heck of it or to add sort of that additional overhead or complexities or because you think it's cool. So why might you require it? You need to satisfy multiple geographies. You need to be able to serve different data sovereignty requirements. You need to span multiple providers or clouds. I know different cloud providers have different offerings. And so maybe you need to like co-locate some services near a specialized offering in AWS or GCP or what have you. Another one that always happens, acquisition has changed everything. You were acquired or you acquired someone, and now your architecture, your system is now spread across maybe multiple providers and multiple regions. And then naturally, a big emphasis on our part is how do you extend or how do you enable systems to extend to the edge? And so that is, we typically think about microservices. We think of, again, there's no bang on Kubernetes or anything, but Kubernetes works really well in the data center. It works really well in a very high throughput, low latency environment. And well, what if you have to go beyond that? What if you have to be able to run clients or whole servers on small devices at the edge? So that's sort of where NATS is really focused on extending out to that. And again, if you have questions, feel free. We want this to be interactive as we go along. This first part is certainly going to be the most number of slides, just to kind of tee up the context. But and then we'll get into some fun demos. So this is not obviously exhaustive, but these are sort of a couple common needs that we think about with microservices. You have your choice of sort of your network or application protocol, and we'll get into a couple details. You have some key value or caching requirements. You have this notion of work queues that might be asynchronous. You have event streaming. Of course, you have the orchestration of containers, VMs, services in general, security and policy, routing, load balancing, service discovery, secret management, and databases. You have all sorts of things.
A lot of stuff.
A lot of stuff. Yeah, right.
Yeah,
it adds up. Yeah. And it's easy again to start small, right? You can have a single service and a database, but when you want to expand over time and you want to serve more customers or again serve more clients, things start piling up because you need to be able to spread that out, and then you need to add all of these additional layers like service discovery, like load balancing, asynchronous queues, caching, all that kind of stuff as you optimize and scale out. So these are things that may not be relevant for an initial design of an application, but certainly it accrues over time. So just a few slides. These are simply examples of, for example, what a modern open source software stack looks for microservices. Obviously not exhaustive. This is just one specific technology choice for each of those prior points that I was highlighting. If your favorite is not on here, I apologize. These are just showing a few examples. And then we can switch over to AWS. If you're kind of all in on AWS, maybe include some more. You can obviously pull in your own open source technologies as well, but if you're using that stack, these are common ones that you might use. If you're in GCP, they have a laundry list of things to support as well. So, and then finally, Azure, you might use some of these.
So I imagine, I mean, a lot of those things that you outlined, Byron, like the idea of why you would need microservices kind of goes against some of these ideas here. Like if you were in an acquisition and you were on GCP and your acquirer is on like AWS or something like that, that becomes kind of difficult, right? to try to consolidate what that looks like and how these things all communicate with each other.
Yeah, exactly. I think it's one of those things where everyone praises the S3 API being this universal object storage API that everyone happened to have adopted across clouds and open source. That doesn't happen very often for really any other technology. So you're gonna be conforming to different APIs to effectively, let's say, connect SNS and Cloud Pub Sub or something between these two cloud providers. You're going to have to figure out how that integration works.
Yep. Harsh said something really funny here. He said, and a pile of shims and Lambda and Azure functions. I think you have a lot of experience with that, right? Working with some serverless stubs and trying to figure out, or it was mostly with, I think it was GitHub Actions or something. Or when you're tied to the cloud provider, no matter what it is, whether it's GitHub Actions or Lambdas or some sort of serverless function over here, one, it's really hard to replicate locally. And then you're kind of tied to that piece of infrastructure in the cloud, no matter what. You get a lot less flexibility in that way.
Yeah, that's right. Yeah. Cool. So, given that sort of information context, this is sort of a list of things that we believe today's microservices, today's stacks, sort of fall short. And these are not trivial problems by any means, and I don't want anyone to take it as, oh, we solved all these problems. But these are sort of the areas in which we believe fundamentally NATS is helping solve and improve upon and simplify. And this is sort of like baked into the design philosophies, the principles of NATS itself. So knowing that you need to span clouds, you need to go to the edge, you need to run on edge devices, having this notion of a perimeter-based security model really breaks down. It doesn't work anymore. This obviously feeds into the whole zero trust movement, and there's a handful of people trying to tackle this problem. NATS is right in there and has a solution to be able to kind of break through this type of perimeter security model.
Yeah, can we talk about that just for a sec? So when you're talking about a perimeter-based security model, you're talking about like, we're going to just put everything inside of our VPC, and that's our secure that's our security.
Yeah, that's right.
And in some cases, like in cloud, we're going to use their very specific, IAM or whatever identity kind of, ACL management layer inside of there, and that quickly becomes a mess and not standardized across platforms. And so, and I think things like the edge really throw a wrench in that, right? Where it's like now stuff has to live outside of that VPC. Like, what are you going to do? And I think that is a problem that I don't think anybody's quite solved yet.
Yeah, that's right. Yep. So having this sort of cloud agnostic, provider agnostic design decisions in creating the security model for NATS, it allows you to be agnostic to any of those things. Of course, if you're going to integrate with local services and those cloud providers, you have to obey to their IAM permissions. But as the sort of connective mesh substrate that actually brings all of these components, these services together to build up your system, you can't really be locked into this perimeter mindset. The other areas sort of following along that, optimize for a single provider. Again, you start with one cloud and that's appropriate, or one provider. That perfectly makes sense as you are designing a system. You don't want to go crazy all over the place. But then the more you get sort of in that vendor lock-in, it's going to be very, very hard to break out of that. And these, of course, AWS services are going to be optimized in that environment. GCP is going to be optimized in their environment. But it's just, if you need, or you fall into a situation that you have to bridge across those, that's again where things get challenging. And I won't. People can read these themselves. I'm not going to go through every single one. I think another big one, however, is the leaky service addressability and the point-to-point service interactions. So those are two things that NATS, being at its core, a publish-subscribe messaging system that allows for end-to-end communication. This is where this can basically solve that problem very, very well, and we'll get into some of that. But I think, again, from a microservices standpoint, we see these giant Death Star type of web of microservices, and they're all talking to one another and doing point-to-point communication. And you have to add all these layers in between, like load balancers and service discovery and all these things, to be able to properly route things. So we'll get to that, but that adds a lot of layers of complexity on top. So again, just quickly enumerating what we actually want: decentralized and zero trust. We want to be agnostic to any provider or sort of deployment compute provider, for example. Location transparency. We want to be able to say, I want to send a message, I want to receive that message, no matter where you are in the world, no matter if you're running in a cloud or at the edge. You have the end-to-end communication, and then more importantly, this being the uniform layer, this, again, connective layer, to be able to bridge all of your services and connect everything together. It just simplifies everything operationally as well. You don't actually need a lot of the things that were listed in the previous handful of slides.
Yeah, because I think, I mean, in a lot of those slides that you listed, we had a lot of different things that were kind of handling communication, right? I mean, we had some form of like RPC handling somewhere, and then we had, some form of message queue, maybe some form of like durable queue for like jobs, and then one that maybe like acted as like an append only log, and we had something for like key value storage, and all of these things at the end of the day. And this is something that Derek likes to say a lot, which is like, at the end of the day, when we have these things communicating, we're either like we're either sending or receiving data, or we're asking a question, right? And so if we just think about this as like bits all floating around, do we really need like all of these solutions to handle it, or is there something better, right?
Yep, that's right. That's right. Oh, we're already here. Great. All right. So this is we'll see if things break. We hope the demo people are supporting us today. So it should be fun though.
Pray to the demo gods, right?
Yeah, that's right.
All right. I'm going to throw up a little banner here I'll wait for your cue, Byron. Do you want to introduce the demo a bit? And we can get people.
Oh, yeah, sure. Yeah, let me share my screen.
So Byron's sharing his screen. This is an interactive demo. These pulled up. I'm going to also kind of put this right here up in the on the video, so you could join it. I'll also type it out in chat in case anybody just wants to click a link. But this is going to be really fun. 2022.vercel.app. All right, Byron, what do you got for us?
Cool. All right. So when you go to that URL, you're going to get just prompted with a little box to enter your name. You can be anonymous. You can just give something unique, some pseudonym, whatever you want. We're not going to really see any identifying information in here. I just wanted to call that out. So first thing you'll see, which is cool to see on my side, this little rocket ship here is the number of people attending. And I have some logs here, just showing as people pile in, which is cool. There it comes in. And if you click the logs, if you're there, you click the logs, you're going to see more people pile in too. You're going to see as anyone who came after you, you're going to be seeing that append. Okay.
Oh, it's ticking up.
It's ticking up. Yeah. So how is this count actually happening? So this is actually using a request many broadcast. And so what that means is that every 5 seconds, it's effectively sending out a request, or roll call request as it's referred to. And your little web application here running locally is replying back to say, hey, I'm here. And so that gets aggregated. So this is actually now sending out 60 plus messages out to all of your machines across the world right now, wherever you are located.
So Byron, this is what you mean by end-to-end communication, right? Where it's like, previously, if this was HTTP, it would all be either like one-to-one, like I sent an HTTP request to you, or technically like load balanced, so it could like go to one person. But you can't really do this with HTTP, where you're like, all right, give me all the people who are interested in this subject, or you can't just like ping a URL and have a roll call come back via HTTP. So this is one thing that I really like about NATS, is you can use kind of these like pub sub fan in, fan out patterns, but in terms of microservices, not just in terms of like messaging queues and jobs and things like that. And it kind of goes to show us like all of our browsers right now are acting as little microservices, right? Scattered all over the world. Because how many countries are people from at this point?
So only about 25% of the people who registered filled out their country of origin, but we have at least 24 countries represented. Wow. For this session. So that's very awesome. Cool. And that actually is going to highlight even more awesome things about NATS and our friends over at fly.io as well, which I'll get into that in a minute.
Now, what's the stuff up at the top? So we have the rocket ship. What about all the other things?
Yeah, sure. So that's obviously your name. You should see that, or whatever value you entered there. This one is showing the closest NGS server that your front-end application is actually connected to. So
and what's NGS again, for those who might not be familiar?
Yeah, good. So NGS is Synadia's SaaS offering that is a globally deployed NATS supercluster, effectively. And it's deployed in all over the multiple countries, multiple points of presence, and multiple clouds. And so you can sort of decipher what server you're connected to by saying, oh, that's the cloud provider that this particular node's running in. That's the region. And then you have a server that's actually running in there. And typically a cluster is composed of three servers, sometimes more, but at a minimum 3 per region. And then you have multiple clusters across regions or across clouds. And all of those are just all networked together. So it's completely transparent from the standpoint of no matter where you're connected up into NGS. I can be sending a request from anywhere and the messages will just flow. The final bit here is actually your round trip time latency to the server. So depending on where you are coming from, there may or may not be a server super close to you. You might have a little bit of latency, but this cluster, this supercluster is always expanding when there's sort of more activity. So we'll play around with this a little bit. So this is sort of like a baseline of latency using an NGS node.
somebody was cheeky, and in the logs, if you go over there and see who connected last, it's somebody made their name HTTP 500 internal server error, which I just think is
Nice.
hilarious. So this is
Love
great.
it.
Yeah, thanks.
Good.
Thanks for the fun interactivity, everybody.
Good thing
So
we're not using any HTTP right now then.
yeah.
Other than Vercel, other than hosting the static web app. Yeah.
So yeah, this is a web app, but it's connecting to NATS. How is it doing that?
Yeah. Great question. So this is using NATS WebSocket library. It's a native WebSocket library that is basically setting up a WebSocket connection, and NATS server natively supports WebSockets. So you don't need to do a raw TCP connection up to NATS. That's the standard protocol. It's a text-based protocol over TCP. However, this WebSocket library that has been implemented by one of the speakers later today that you'll meet, he implemented the WebSocket library so it can just run in the browser. It establishes a WebSocket connection up to the NATS server, and then all of the messaging that you would expect with NATS just flows over a WebSocket connection. So it makes it pretty cool to be able to just create web apps by using WebSockets, and you don't have to throw anything in between your application and the NATS server.
That's great. Yeah, and so it kind of does create this dynamism of where, yeah, you can use WebSockets to maybe create like a chat app or anything like that, connecting directly to NATS without a backend, which is pretty cool. But also, we're kind of, again, simulating the dynamism of having a globally distributed set of microservices, right?
Yeah.
And I think this is
Yeah.
what you're going to talk about maybe with this greeter button that you have over here. What does this greeter button do?
Oh yeah, so these are just little tabs here. So you saw me switching back and forth, and
Yep.
this greeter is just a trivial service, but there's a lot of fun things to that we'll see as the session evolves. But so everyone can go in, and you probably have already clicked things, because I know I like clicking UIs when I see them the first time and try to break stuff. But if you simply hit send here, oh yeah, definitely people have been hitting it. You hit send. And so what this is doing is that it's sending a request from the application up to a service that has been deployed. There's a single instance of a service deployed in Los Angeles, and it's running on Fly. And you can see that service is connected. I included all this metadata again to sort of build up the point and sort of how easily it is to connect everything from all over the place. So we'll keep an eye on some of these details. So this one's in the Los Angeles region in the US. It is connected, that service is connected to this node in NGS. So it's different. It's in an AWS cloud, this different region, west, as you would expect, and completely different from my node that I'm connected to currently. And the round trip time from me, from this node essentially, all the way to US West and then back is 139 milliseconds. So that's your round trip time latency. So that's what that means. And of course you can change your message if you choose to, and that's cool, but it just defaults to your name for right now.
Very cool. So we're kind of acting as microservices for that roll call, but now we're also kind of talking to different microservices that are, in your case, this fly.io, the hosted service on fly.io, this greeter, is all the way over on the West Coast. And you're talking to a NAT server that's on the East Coast, and it's getting routed all the way over there.
Yeah, that's right. So, yep. So I just wanted a quick call out Fly. They're good friends, partners of ours. They have a really nice hosting environment. And the reason is because they actually have a whole bunch of regions to deploy to, which is going to make the demo even more fun. So if you find your closest city on this map, I'm going to be deploying to all of them, so don't worry about it. But see if you can find maybe the closest region to you. All right. So that's, I think, it for this segment. We have a couple more slides just to kind of reinforce the HTTP integration, the web integration. So let's kick back over there. Cool. So this is always a common question. So I think it's worth talking about. which is people build web applications. It's the dominant way that clients are presented and people interact with applications. So obviously you have mobile phones and things like that. But if you're building any kind of user interface, the web is definitely a dominant choice there. So it's all to say that NATS plays very nicely, as you can see, through the native WebSocket API. And there's also a handful of other choices to be able to bridge between sort of native HTTP requests from the browser, whether they're sort of JSON over HTTP or sort of a RESTful representation of your URL structures and things like that. There's very simple shims that can be deployed to be able to do nice translation directly from native HTTP requests into a NATS message and vice versa. So when people see like, oh, this is a new protocol, this is like not HTTP, this is not gRPC, which is just HTTP under the hood, people get a little nervous. They're like, should I really adopt this? Is this going to cause challenges? The answer is no, it's not. But you also have to think about sort of the positioning of NATS is really about connecting all the other things within your bigger system. And typically these sort of like edge is overused here, but client facing components like UIs and stuff like that, that sort of can always be layered on sort of on the perimeter of your system, like a common term, ports and adapters, hexagonal architecture, things like that. You can have this HTTP sort of adapter that is allowing messages to flow between kind of web native clients and your NAT system.
Great. We have one question that kind of came up in both the QA and in the chat. Nicholas asked, how are you authenticating these clients? And that's a really good question. We can talk about how we're doing it right now, and then as well as some other questions of like, what's best practice here when you're using WebSocket? So Byron, do you want to talk about currently what we're doing to authenticate the clients and how we break it down?
Yeah, sure. So it's again, demoware, but a super basic way to use a bearer token. So it's effectively a minted bearer token, a JWT, that is allowing the clients, the web app, to actually authenticate up to NGS in this particular case. And so we could have a whole talk on this itself, but essentially it's a user that has a certain level of permissions that is a part of an account within NGS. And then that account is completely isolated from all other accounts. That's the whole nice multi-tenancy feature of the security model in NATS. And so, yeah, this is just a simple JWT token embedded in the web app, and it's just shared currently. So we're not
right.
doing
Okay.
anything
So this is
fancy
shared
right now.
amongst all of us. We have the same user right now, and you
Yep.
could still put limits on it and stuff like that. But one bad actor could ruin the whole bunch. And create
Yeah, that's right.
for us in kind of a best practice scenario, because this was just a demo for us and it's kind of publicly facing. We wanted it to be easy. We didn't want you to have to log in with a user account or anything. But the way we've done this in practice is you can create a backend either using HTTP or even NATS on a different channel if you wanted to. That you can use to essentially authenticate. You would exchange maybe a token that you care about, maybe your JWT for your application or for your identity provider or whatever. And that backend would then understand who that JWT is and what that identity is and being able to issue a NATS JWT for that. And so you feel free to pop into our Slack channel or our support channel for NATS. We've done this a ton. And it all kind of comes down to like what your backend is for your identity and how you want to be able to issue those JWTs. But we have a lot of customers that are issuing JWTs on the fly as bearer tokens with like very short windows for expiration. So because they can always just reissue them very easily. And so I have a couple like proofs of concept where I've done it with like OpenID Connect and like Google authentication, for instance. So you can like sign in with your Google and then I mint you a JWT, for your user on the fly. And it's a pretty nice system. We also have some things that we're working on kind of on the back end inside of the NAT server to make sure that that's even easier, that you can maybe do that in a single connection. Yep. Great. That was a great question. Let me see if anything else pops up. Maurice did ask a pretty good question here. Let me pop it up in a little banner so we can all see it. He asked, all being connected via WebSockets just now, are there any settings regarding rate limiting, only allowing X requests per second, for example? So when you're minting user JWTs, you can set limits on all of those, just like you can with any other NATS user. And so, yeah, things like limits on how many messages they can send and everything like that can also be done, which is pretty cool. Great. Awesome. This is really cool. I think we can definitely push a lot more of this idea of that NATS can actually play really well with like web standards, which I think is really neat.
Yeah, absolutely. All right.